Okay, starting chapter 8 now, question 7. Given this sequence here, we have to write an expression for the nth term, or in other words, find the explicit formula So first we need to figure out what kind of sequence this is. If you look at the terms 3, 9, 15, 21, 27, we're adding 6 every time. Since you're adding the same number, this is an arithmetic sequence. An arithmetic sequence the common difference is 6, since we're adding 6 to each term. So in arithmetic sequence, the explicit formula is like a linear function, mx plus b, where m is the slope or the common difference. So we're going to have 6n, and the next term here, plus or minus some number, it's like the y-intercept of a linear function, y equals mx plus b. The y-intercept happens when x equals 0. So it'll be the same thing as finding the 0 term of the sequence. This term right here, the 3, that's the first term. If there was a term in front of that first term, it would be negative 3. Because if we added 6 to negative 3, you'd get 3, and then 9, and then 15. So negative 3 is like the 0 term. So 6n minus 3 is the explicit formula. And it helps to always check the formula. Once you have a formula, check it to make sure it works for the sequence. So if we plug in n equals 1, for example, into this formula, 6 times 1, so I'm talking about this explicit formula here, 6 times 1 is 6, 6 minus 3 gives you your first term, 3. We plug in a 2, 6 times 2 is 12, 12 minus 3 is 9, so it gives you your second term. So the formula seems to work. Now the 29th term, once you have the explicit formula, is pretty easy. A sub 29, that's the 29th term, equals 6 times 29 minus 3. 6 times 29 is 174, minus 3 equals 171. Okay, write the first 4 terms of the sequence given by this recursive formula. This right here, a sub 1, tells us the first term is 5. So we just need the next 3 terms there to get our 4 terms. Now, this part of the recursive formula, this is the part that tells you how to get the next term. That's what this right here does. So a sub n is the term that we're looking for now, a sub n. A sub n minus 1 means the previous term, which is that term. So a sub n, which is this, is equal to the previous term 5 plus 6. So 5 plus 6 is 11. And then you just keep following the same pattern over and over again. Add 6, add 6, add 6. So the next term is 17, then 23, and so on. Okay, number 9, evaluate. This symbol here, the sigma, means summation. That means we're going to be adding terms. We're adding, starting with the first term up to the 15th term, so adding 15 terms. Now it's not a great deal of terms we're adding together, so you could just write all the 15 terms out and add them all up separately. But there are formulas for partial sums of sequences. In this case, given the explicit formula, 4n minus 4, that's a linear function, so this is an arithmetic sequence. The partial sum of an arithmetic sequence This is that story I told in class about Carl Friedrich Gauss figuring out how to add the numbers 1 through 100. So we added the first term plus the last term being added and multiplied it by half of the number of terms being added. So in this case, we're adding 15 terms, so n equals 15. In order to get the first term here and the last term that's being added together, we have to use the explicit formula here, 4n minus 4. So to get the first term, you let n equal 1. 4 times 1 is 4. 4 minus 4 is 0. So the first term is 0. To get the last term being added, you look at this number, 15. 4 times 15 is 60. 60 minus 4 is 56. We're adding 15 terms, and you divide it by 2. And this turns out to be 420. Okay, number 10, the sixth term of an arithmetic sequence is 17, the fourth term is 11. Find the 12th term. Now, key is that the sequence is arithmetic. Arithmetic sequences can be modeled with a linear function. Like this one here, 4n minus 4, that's a linear function. That means it's a straight line. Trying to connect the world of sequences to the world of functions, the number of the term, like the sixth term, could represent an x value, and the actual term in that spot could be the y value. So 6, 17 we could think of as a point on a linear functions graph. And the same thing here, the fourth term is 11. That means 4, 11 when n equals 4, the term is 11. When n equals 6, the term is 17. So with a pair of points like this, knowing that it's linear, we try to figure out the slope. So the slope is the change in y, 17 minus 11, over the change in x, 6 minus 4, and we get 6 divided by 2, which is 3, so the common difference is 3. So if we wanted to start making an explicit formula, a sub n equals 3n plus, and then we don't know the starting point here. But what we do know is a couple of points over here. So if I choose this one, for example, 4 could act as an n value to place right here for n, and 11 could act as an a sub n value to place there. That would help me find this unknown number for that question mark. So what I'm going to do, I'm going to place 11 for a sub n, 4 for n. 3 times 4 is 12. 12 plus some unknown number has to equal 11. That means that unknown number is negative 1. So the formula is a sub n equals 3n minus 1. Now, the reason we would want to have a formula is now we could find the 12th term by simply plugging in a 12 for n in the formula there. 3 times 12 is 36. 36 minus 1 equals 35. So the 12th term equals 35. Number 11 is expressing the partial sum using sigma notation. So they want us to generate something that looks like this. We don't actually have to find the sum, we just have to have a sigma symbol starting, and we're assuming that this is the first term. So we're going to say n equals 1, and we're adding 1, 2, 3, 4, 5, 6, 7 terms. And we just need the explicit formula here. Now it depends on if this represents an arithmetic or a geometric sequence. So if we're looking from 2 to 5 to 8 to 11, we're adding 3 every time. So it's arithmetic, and since the common difference is 3, it's going to be 3n. And now we need this term here, 3n plus something or 3n minus something. And this term represents a zero term of a sequence, the term that would come in front of the first term. If the pattern continued, there would be a negative 1 right there. So, negative 1 right there. Happens to be the same sequence as in problem 10. For question 12, find the ninth term of the geometric sequence. Finding any term of a sequence is easiest if you have the explicit formula for it. Now since it's geometric, the formula a sub n is the first term a sub 1 times the common ratio to the power of n minus 1. So looking at our sequence here, we have 27, that's obviously our first term right there. But then 27 to 9 to 3 to 1, what are we multiplying by to get from term to term? We're multiplying by 1/3. So the explicit formula is 27 times 1/3 to the n minus 1. So now that we have the formula, we could find the ninth term, a sub 9 equals 27 times 1/3 to the 8th power, and this equals 1 over 243. Okay, question 13. Find the sum of the infinite geometric series. And it says if possible, because the only time that you can have an infinite sum of a geometric series is if r, or the absolute value of r rather, is less than 1. So we've got to figure out the common ratio. So to go from 2/5 to 4/25 to 8 1/25, we're multiplying by 2/5. So r equals 2/5. So that means that it is possible to find an infinite sum. The formula is first term over 1 minus r. There's the first term, and there's the common ratio. So it's 2/5 over 1 minus 2/5. So that's 2/5 divided by 3/5. It's the same as 2/5 times 5/3, which is 2/3. So for this one, it's another infinite geometric sum that they want us to do. The rule still applies though. This is only possible if r, or the absolute value of r, is less than 1. So looking at the explicit formula, this term right here inside is equal to r. R is 1/11th, so that means that we are going to be able to find an infinite sum. The formula is first term over 1 minus r. You've got to be careful about this explicit formula that's been given here though. This is not the first term, -2. That coefficient is only the first term, and I've explained this a few times in class, if the exponent is n minus 1, which it's not, right here. The exponent is just n. If the exponent were n minus 1, then that would be the first term. But since the exponent is just n, we have to find the first term by letting n equal 1. So I put a 1 in for n, we have -2 times 1/11th to the first power, which is just 2 11ths. There's your first term. So we have negative 2 11ths divided by 1 minus, and r is 1 11th. So this is negative 2 11ths divided by 10 11ths, which is negative 2 11ths times 11 tenths, which turns out to be negative 1 fifth. Yeah, so we have a first term and a third term, but the second term is missing. We're supposed to find a value for which the sequence could be arithmetic or it could be geometric. So let's start with part A of the arithmetic. Arithmetic means we're adding the same number every time. So 6 plus a number brings us to x, and then x plus that same number would bring us to 12. Now most students are pretty easily able to figure out that x has to equal 9. If you place a 9 right there, then it's pretty much halfway between 6 and 12. You add 3 to get to 9, and then you add 3 to get to 12. You're adding the same number every time, so x has to equal 9. That's fine to be able to do it in your head with an arithmetic sequence. It's a little bit harder to do it with a geometric, so here are a couple of algebraic ways. If the sequence is going to be arithmetic, that means that the explicit formula could be a linear function. And we already know the first term. First term in n equals 1 is 6. Let me write this again. 1 comma 6. 1 for the first term, and 6 meaning that the term is actually 6. The third term is 12. And since it's arithmetic, we know that this is going to be a straight line, so we can find a slope. 12 minus 6 is 6. That's the difference in y. 3 minus 1 is 2. That's the difference in x. So the slope has got to be 3. And remember, slope for arithmetic sequences is like the common difference. So we know the common difference is 3. That means if you add 3 to 6, you're going to get 9. If you add 3 to 9, you're going to get 12. So x has to equal 9. That's one way to figure out the common difference. Another way, and this is the way we're going to do for part B. Another way to do this knowing that this is arithmetic, that means there's going to be a common difference. We know it's 3, but let's assume that we don't know what it is. If we start with the first term and add that common difference, zoom in here. So if we start at 6 and add the common difference, that's going to bring us to that number there. Now if we start with that number x and add another common difference, well, the same common difference, but one more time, that's going to bring us to 12. So 6 plus d brings us to x, and x plus d is going to bring us to 12. So if we're taking a look at going from 6 all the way to 12, 6 plus 2d is equal to 12. That's what separates 6 and 12. There's two common differences there. And if we solve this, it's a pretty easy equation to solve. We get that d equals 3. That's the common difference. So that now that we know d is the 3 is the common difference, 6 plus 3 is equal to 9, which brings us our answer, x equals 9. Now we can do the same thing for the geometric. Geometric means that we're not adding the same number d, we're multiplying by the same number r. So 6 times r would bring us to the next term x, and then x times r would bring us to the next term 12. So if we do the same thing, thinking about what separates the 6 and the 12, we're multiplying by r. So 6 times r times another r is equal to 12, or 6r squared is equal to 12, which means r squared is equal to 2, so r equals plus or minus the square root of 2. So this one's a little unusual. R could actually equal two different values. plus or minus the square root of 2. So depending on which r value we're using, we can get a different value for x. We're going to get two answers here for part B. So let's say that if r is the positive square root of 2, then to figure out the value of x, it says right here that x, if we look at this, x is just equal to 6 times r. So x is equal to 6 times the square root of 2. If we're going to use the negative square root of 2, then x would equal negative 6 times the square root of 2. And this is a little unusual. Usually the terms of a sequence are integers. It just so happens that the missing term there in the middle of 6 and 12 is 6 square roots of 2 or negative 6 square roots of 2. And just to help you understand how this works, the next term would have to be 12. So we've got 6, and then we have 6 square roots of 2. The next term here is supposed to be 12. So if we take 6 square roots of 2 and multiply it by the common ratio square root of 2, these two multiplied together, square root of 2 times the square root of 2 is just the square root of 4. The square root of 4 is 2. 6 times 2 is 12. So it does give us the next term, or the correct next term, which is 12.